Hello friends, welcome to my channel. In this video I will cover GATE previous year papers, strength of material, design and engineering mechanics. Second session I will cover. This is part 3. Question is, the principal stresses at a point in a critical sections of a machine component are sigma 1 equal to 60 MPa, sigma 2 equal to 5 MPa, sigma 3 equal to minus 40 MPa. For the material of the component, the tensile yield strength is sigma y equal to 200 MPa. According to the maximum shear stress theory, the factor of safety is how much? Factor of safety we have to calculate. So first data given are sigma 1 equal to 60 MPa, sigma 2 equal to 5 MPa, sigma 3 equal to its negative 40 MPa, sigma y tensile yield strength given it's 200 MPa, factor of safety we have to calculate. So from here yield shear stress we can calculate, it's sigma y by 2, 200 by 2 it's 100 MPa. So maximum shear stress theory we have to use. For maximum shear stress theory, induced shear stress, maximum value of induced shear stress, it should be less than equal to yield shear stress divided by factor of safety for the safety of the component. It should be less than or equal to sigma tau y divided by FOS, factor of safety. So from here we will get the value of factor of safety. First, maximum value of induced shear stress we have to calculate. So maximum value of tau induced, maximum, it's maximum of sigma 1 minus sigma 2 by 2 or sigma 1 minus sigma 3 by 2 or sigma 2 minus sigma 3 by 2, or we can write sigma 1 by 2, sigma 2 by 2 or sigma 3 by 2. So if you try, maximum value we will get here sigma 1 minus sigma 3 here. Here we will get maximum value. Sigma 1 is 60 minus of minus 40, we will get 100 by 2, it's 50 MPa. So shear stress maximum induced is 50 MPa. So then put the value, we will get our answer. So here induced shear stress maximum should be less than equal to yield shear stress divided by factor of safety for the safety of the component. For safe design, its value is 50, it should be less than, already we got yield shear stress value is 100 divided by factor of safety. So factor of safety should be less than equal to 100 by 50, it's 2. So 2 is our answer. So from option B is our answer. Question number 50. A rod of length 20 mm is stretched to make a rod of length 40 mm. Subsequently, it is compressed to make a rod of final length 10 mm. Consider the longitudinal tensile strain as positive and compressive strain as negative. The total true longitudinal strain in the rod is how much? So initial length is 20 mm and final length it's 10 mm. Finally it's 10 mm. Then we have to calculate 2 strain equal to ln initial area divided by final area, or it's equal to ln of final length divided by initial length. So ln final length it's 10 divided by 20. So ln of 1 by 2 minus 0.69. B is the answer. Thank you friends. Thank you for watching my video. Thank you.